Okay.
And if there is a not measured pressure release valve will not measure if there is any increase
If
in
the
the
pressure is more.
then the required, then it will release us the pressure. That you say means everything you have to cover, whatever you have diagram in whatever it is there, no, you have to cover everything. So you mentioned that. And how the oil will enter, how the fluid enters between the two gear.
So as our area start decreasing over there,
That is a suction will take place because of that. Because of the area difference, volume difference.
Due to the
Don't tell the area. Tell the
volume
means,
because it's 3D.
Yeah, one guy has got rejected because he told the area. So don't mention the area. Tell the volume. Okay.
Okay. So it's trapped between the gear teeth and the casing.
Hello.
Yeah, I am audible.
Yeah. You are getting stuck in between means because of internet or maybe.
Yeah. It is going to trap between the gear teeth and the casing.
Yeah, how it is getting trapped means I will only say whenever there is a section because of the volume difference, the pressure difference will take place. Okay, inside
At
the casing and
the
outside.
pressure difference,
At the
that
section
the
side. Because
suction
of
pressure
that
created
pressure,
between the teeth, and because of mechanical meshing of gear, use the term mechanical meshing of gear, that the trap because of mechanical meshing of gear, the fluid get trapped into the teeth of gear, and that forces the liquid at the discharge side, and discharge side we see the volume decreases, and so volume decreases accompanied by the pressure increases at the discharge side, that is further checked by the pressure relief.
Okay.
Yeah. Understood.
So because of the mechanical meshings of gear, basically
yeah,
it is.
You want to say again or it's fine? Let's move on.
No, it's fine. I will give you the mock interview later.
No. Try to fine. Say it again right now here only. Then only you will learn.
Because I want you to get practiced. That's why I'm asking.
Okay, I am going to start it. Explain from the start.
Fine, yes.
Okay, so gear pumps is basically a rotary positive displacement pump in which there is a driven gear and the driver gear is there. As they start rotating, so as they start rotating at the inlet side, due to the mechanical meshings of gear, its volume increases over there as the fluid enters into the inlet pipe. So due to the mechanical meshings of gear, the fluid is trapped between the teeth and the casing. So with that,
fluid is getting entrapped between the two teeth because of the suction pressure is created between the two teeth. No, because of that, fluid will get sucked between the two. See, you only imagine it is going inside because of the difference in the volume. It goes inside. Okay, after going inside, it has to get entrapped between the teeth. No. So that entraption which it gets, no, that is because of the suction pressure created between the two teeth.
So as they rotates,
there is as they rotates, there is a gap between the two teeth. No, there will in between the two gaps there is a suction pressure created. Because of that suction pressure, the fluid will get trapped into the between the two teeth, and it will get discharged into the distance. Like that it will.
Okay. So as the volume
this is the machine. So here this pressure over there. Yes. So with that it goes into it trapped into that two gear and the casing. Due to that rotating part, it goes into the discharge. Yeah. That was good. Okay, then yeah. Okay, next explain VCRS system. Draw the diagram and explain the VCRS system. Now done. SP cutout, LP cutout you didn't do.
Yeah. SP cutout and LP cutout you didn't do, and inlet pressure gauge and outlet pressure gauge also is missing, and condenser little this side is your yeah. And this one seawater inlet and outlet you did no, it's like that one.
Yeah.
Yeah, the rest of
HP cutout and LP cutout. It's quite, I don't know much about it.
it's basically only if there is a high pressure name only suggest what it is. So nothing much is there about it, and he will not specifically point out that and ask the explanation. He will ask overall explanation. So you need
Yeah,
not
okay.
to worry.
It's like that, no? High pressure is between the compressor and between the dryer.
Yeah.
Between the thermostatic expansion valve, and the low pressure is like
after compressor, before compressor there is a maybe
Low
there
pressure.
will be a low pressure cutout, and after compressor there is a high pressure cutout.
yeah. Yes.
That much only. And inlet pressure gauge and exhaust pressure gauge. That much only is there. Okay,
Yes.
explain the VCRS system.
Okay, so at starting from the compressor, the vapors of the refrigerant goes into the our compressor. The function of the compressor is to compress the refrigerant and to increase its temperature as well as its pressure. So after passing through the compressor, its pressure increases up to 19 to 22 bar with very high temperature.
Don't mention the temperature.
Okay. After passing it from the compressor, its pressure increases as well as its temperature increases. Then it passes through the condenser, where with the help of the seawater, its phase changes and with the same pressure, the gas refrigerant is converted into the liquid refrigerant. That means its phase changes with the constant pressure. Okay, then refrigerant has to pass through the dryer. The function of the dryer is to that if any of the moisture is present into the refrigerant, it will get extracted. Okay, then after that, the refrigerant will pass through the thermostatic expansion valve. In that there is a orifice is there. After passing through that, our sudden pressure drop happens and the temperature also drops happen. So our liquid refrigerant is converted into the liquid plus vapor forms. Okay, then our liquid plus vapor refrigerant goes into the condenser, where our
Goes into the evaporator. Goes into the evaporator. You told condenser.
Goes into the evaporator. The function of the evaporator is to extract heat from the liquid from the refrigerant, and after that it passes through the sensing bulb. The sensing bulb is connected with the thermostatic expansion valve with the capillary tube. The function of the sensible plug is basically, if the load on around 5 to 8 degrees, more than 10 degree or more than 8 degree, so it will sends a message to the thermostatic expansion valve to send some more fluid, so that only the vapor will go into the compressor. Okay, yeah, that's it.
Okay, you told a sensing bulb as a sensing plug. That is one mistake. And the second mistake is in a dryer there will be a silica gel. You missed that point. The silica gel helps to extract the moisture. So two things you have missed.
Silica gel. Okay, just let me write it.
question is, what are the compressor safety devices?
So compressor safeties are sir. First one is safety valve.
Yes.
Okay. Second one is unloader valve is there. Then bursting disc is there. So
Yes.
then after that a low lubile pressure.
Yes.
Okay.
Low
Drain
lubile
valve is
pressure
there.
Low lubile pressure
Yeah, low
trip.
lubile pressure trip and alarm.
Yeah.
Then one more thing is there. Okay, a cooling water jacket temperature.
Yeah.
Okay. Then drain valve is there, sir, and some
Yes.
pressure gauges are there.
Okay. Right. Then auxiliary engine safety devices.
Sir, it is most of the safeties are same as like the compressor.
Same.
Okay, it's like a cooling water jacket temperature, low lubile pressure alarm and trip. Then one more thing is here. Let me recall. Crankcase relief valve is there. Thermometers are there. Pressure gauges are there, and overspeed trip is there.
Yes, engine overspeed trip, and in a two-stroke engine there will be oil mist detector. That one.
Just wait a second. Let me write this one also.
I specifically asked this because the oil mist detector. He asked some person what is oil mist detector and all. So because of that I mentioned.
Okay, it is in two-stroke, na?
Yeah, in two-stroke it will be the oil mist detector.
What is that name?
Oil mist detector. Mist. 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 Hello.
Yeah. What's its function? Hello.
Yours internet I don't know, means like it's stuck. It is getting stuck.
No, it's okay.
Now it's fine.
Okay. What's its basically function?
Oil mist detector, what it does, because what it does is whenever there is something defect will be there inside the crankcase, no. So at that time there will be a crankcase hotspot is created inside the crankcase. This hotspot is abnormally increase in temperature in some spots of the crankcase. Because of that, the oil will get vaporizes, and it will whenever it get condensed, no, mist formation will happens. Okay. Because
let me recharge.
Okay. Sorry, I took more time because of that.
No problem. I need more later.
Okay.
Yeah, now you can explain. Just start explaining. What is oil mist detector?
In the inside the crankcase, if there is any defect will be there. If there is any defect happens, no, because of that there will be abnormal increase of the temperature inside the crankcase. So that is called as a crankcase hotspot. Because of crankcase hotspot, the lubrication oil will be vaporizes, and it will after some time it will get condensed. So mist formation will happen. If this mist formation is will happen, no, because of the high temperature, sometimes lube oil catches fire. So, because to avoid this, oil mist detector is there. As soon as the mist formation will take place, oil mist detector will detect the oil mist, and after that we can do whatever rectification can be done after that. This is what the function is. Oil mist detector. Okay.
Okay. Yeah.
Okay. Then refrigeration safety devices. What are these?
Low pressure cutout, high pressure cutout, low lubile pressure.
Yes.
And then safety valves are there. Yeah, that much I know.
Yeah. Other than that, you have to say like cooling water, low pressure cutout in condenser.
Just a second. Cooling water.
Cooling water, low pressure cutout in condenser.
Low pressure cutout in condenser. Okay.
And oil heater.
Oil heater.
Yeah, that is there.
Where it is placed,
It is placed in the crankcase in compressor. Use it to heat the crankcase in compressor. In a compressor, it is used oil heater. And another is bursting disc is used.
Okay.
Yeah, these are the three.
Okay.
And cooling water, low pressure cutout in condenser, what it does means if the pressure is less in whatever you circulate, seawater is going to circulate inside the condenser, right? If the pressure of the seawater is less, no, then circulation will not happen inside the condenser. Because of that, the heat extraction will not take place from the refrigerant to the condenser means like between them. So when there is no circulation of the seawater, so because of that we will use the cooling water low pressure cutout in condenser. So to continue the circulation of the seawater inside the condenser. This is the basic function of that. Okay. Okay. Next question is the difference between the 4-stroke and 2-stroke.
Okay, so starting from the in 2-stroke, we have basically 2-stroke, that suction and suction and compression take place in one stroke, and power and exhaust takes place in another stroke. In 4-stroke, basically we have 2-stroke like suction, compression, power and exhaust. In 2-stroke, so 2-strokes engines are basically reversed in direction, and 4-strokes are unidirectional. In 2-stroke, we can burn low quality of fuel as by increasing the stroke length, and in 4-stroke, we don't have the longer stroke length.
In this point is I prefer you not say, because I asked the merchant navy candidate one person. Both the same quality of the oil is used in a 4-stroke and 2-stroke. So because of that, this point is invalid.
Okay.
Yes, sir has wrote, but I when I asked the person, no, so he told I thought that this is one of the reason because of which the 4-stroke is used as a main engine and 2-stroke is used as a main engine and 4-stroke is used as an auxiliary engine, but this is not the reason. So you cannot say because the same quality of the oil is used, no, then it is getting.
But for starting the auxiliary engines, we need diesel.
Starting the auxiliary engine, we need diesel.
Okay. Yeah, in 2-stroke, we can use the large. In 2-stroke, we use the smaller flywheel, and in 4-stroke, which is the larger flywheel. In 2-stroke, basically power to weight ratio is more, as we can load more carrier, more cargo on the 2-stroke engine rather than the 4-stroke engine. 2-strokes are basically in 2-stroke, it has a less volumetric efficiencies than the 4-stroke, and high thermal stressors is on the 2-stroke at the start of compression than the 4-stroke, and yeah, that much only I am able to recall now. Your mic is on off. The mic is off.
Okay, sir. You missed the cam is to crank ratio is 1:1 and 1:2. That point you have missed. And the lube oil cost is less. That is, if you didn't tell also, it's fine. But torque produced will be more in a 2-stroke and compared to 4-stroke. That 2 points you have missed. Rest all you have told. And fuel consumption will be more in a 2-stroke and compared to the 4-stroke. That one.
I know these, but I don't know if he asked the cross question. How the 2-stroke engine have the more fuel consumption, then that's
because in 2-stroke you use the crosshead, no, means like a larger stroke length will be there. Stroke length is more, because of that you can put the more amount of fuel in a 2-stroke compared to the 4-stroke. 4-stroke there is no the crosshead is there, because the number of the revolution is more in the four stroke and less in a compared to the two stroke. So because of the more stroke length, you can use the more amount of fuel inside the two stroke compared to the two.
Okay, and one more point I want to add. And then two strokes have we have two in two stroke we have ports, and in four strokes we have a valves arrangement.
Valves, yeah, you can.
Yeah.
And two stroke can be reversed in a direction. Four stroke, you told.
Yeah, that I told in the first.
Yeah.
And crank to cam rotation in crankshaft to cam shaft rotation in two stroke is 1:1, and cam shaft to crankshaft rotation in in four stroke is 1:2. Just because in four stroke we have the gear arrangement, and in two stroke we have the belt or belt arrangement. Chain support we call it.
What happens if the wall clearance is not given between the rocker arm and the valve stem? What happens if it is not
then the thermal expansion is not take place. Proper thermal expansion is not take place, and the proper opening and closing of the valve does not take place due to that improper combustion, and knocking can happen.
Yeah. And another thing you can add is because of that, if the clearance, what happens if the clearance is less in between the rocker and valve stem?
Valve will open if the less valve will open late and close early.
Most of the time, the wall will be kept open. That is what answer I got. So
I am not able to recall now.
Yeah, because what happens if the rocker this is a rocker, okay, and this is a valve stem. If the clearance is less, no. So because of that, most of the time valve stem will kept open. Because of that, what will happen means most of the time valve kept open means during the compression stroke, the not enough pressure generation will not take place. So because of that, fuel is not burnt completely. So the efficiency will eventually get reduced. Okay. And both the valves will keep the same amount of clearance or a different amount of clearance?
No, exhaust valve have the more clearance than the inlet valve. Yeah. Because of the thermal expansions.
Yeah.
Because in the exhaust valve we have the high heat. We have the heated that exhaust gases.
Yeah, exhaust gases will we need more and high.
Yeah, we need more clearance in the. Okay.
Yeah, got it. And difference between the centrifugal pump and positive displacement pump?
The centrifugal pump works on the centrifugal law.
Rotodynamic law. It's not centrifugal.
Rotodynamic
principle.
Principle. Sorry. In positive displacement pump works on the positive displacement principle. Is it like that?
Yeah, it's
in centrifugal pump basically used where we need large discharge, not very much pressure is required, and positive displacement pumps we used where we need high pressure.
Yes.
In centrifugal pump there is no safety valves, and in positive displacement pumps we are using the safety valves.
Yes.
Relief valve. Sorry, it's not safety. It's a release valve, and efficiency affected in centrifugal pump is generally due to the increase in area. Is generally due to by changing the load, and in reciprocating pump, efficiency affected by the increase or decrease in the pressure. Okay. Then load on the motor in centrifugal pumps increases if our flow rate increases, but in reciprocating pump load does not vary. Okay. Then in centrifugal pump we are not dealing with the high viscous fluid, and in positive displacement pump we have to basically we are dealing with the more viscous fluid. And centrifugal pumps are basically used in seawater pump, main engine lube oil pump, emergency and fire gas pump, and reciprocating pumps we are using for transferring the fluid we are using the gear pump and screw pumps, and for 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 extracting or scraping the oil from somewhere that is separated out. We are using the that piston pumps.
Okay. What is purging?
Sorry,
Purging. What is purging?
purging. Sorry, so I am not able to recall this.
It is there in a centrifugal pump basically. In the what you will say, filter is there, no, means like footwall and strainer. Strainer
Yes.
is also called as a filter. Okay. In
Yes.
that filter, whenever you want to clean the filter, whenever the choking happens inside the strainer or filter is there, no? At that time we will remove the strainer or a filter, then we will clean it. Okay, we will clean it, and when if we clean it and if you put it directly, there will be, if you on the pump, there will be the chances of air going inside the centrifugal pump. Okay, to avoid this, we will, after cleaning it, we will put the oil. After fitting it, we will put the oil inside that, so that all the air comes out through the strainer. Means all the air get all the air, we will remove all the air after putting the oil. So this process is called as purging. So this question is also asked by someone. I don't know. I just remembered it, so I asked it.
Okay, perfect.
What is that?
Yeah.
Can you tell me again?
I told you before also, yeah. This one purging, this is in a strainer. In a
It is-
centrifugal pump, there will be a strainer. Hmm? Okay. You explain.
Yeah, if I'm wrong, just let me interrupt. Okay. Like it is used in the strainer, like when we are if our strainer gets choked while cleaning the strainer, we move it now. So if we did not okay, so after that we just put the split the oil on the strainer so that the air will not suck into the pump. Is that it?
Purging is done basically on the filter. We always use the term purging the filter. Purging the filter means cleaning of the mud from the strainer or filter and putting some oil on it. Can we say that?
Yeah, that but he
Yeah,
explained.
see, once there will be a filter, no, in the strainer. If strainer gets choked, we will remove that the filter and we will clean it. After cleaning it, we will put it back, and then we will put some oil inside that filter, so that all the air gets evacuated from the filter. And so no more air. We will ensure that there will be no more air inside the filter. Then only we will on the centrifugal pump.
All right.
So the process of cleaning the filter is there, no, through the oil by removing the air. This process is called as purging.
All right. All right.
The process of removing the air from the centrifugal pump is called as priming, and removing the air from the filter is called as purging.
All
Only
right.
this much is the difference. Understood, no?
Yeah.
Filter. Yeah. Okay. Next
Yeah.
question.
Okay. Next question. Cavitation I asked. Okay. Difference between the rotary pump and the reciprocating pump. Tell me.
Actually, I am not having this question, but let me explain. In rotary pumps, we have a gear pump and a screw pump, low pump, and vane pump. And in gear and in what was it? Another
Reciprocating
one?
pump.
In reciprocating pump, we have the piston pump and the diaphragm pump. In reciprocating pump, we have the piston move up and down process, and in rotary pump, we have the that rotary process is there.
Yeah, gear you can tell, no? Gears
Yeah,
we will
okay.
use to
Gears, yeah. Gears we are
Okay, next
using.
one.
Okay. And in reciprocating pump, we are not dealing with the high viscous fluid.
Okay.
Is it? And in
No,
rotary pumps, we are
that is wrong. That is wrong. In both reciprocating and rotary, we use the viscous fluid only to transfer.
Okay.
In reciprocating pump, we can use water also, but in gear pump, in this rotary pump, we cannot use the water.
Okay.
Viscous fluid is common in both.
Just let me think more. I'm not able to recall. Just tell me. We can use
Okay,
watering.
Gyan, are you trying to try to explain difference between this? It will be revision for you.
Okay, what is the question?
Difference between reciprocating pump and rotary pump.
Okay, rotary pump works on positive displacement principle, and reciprocating pump works on the reverse piston movement principle. Okay, and reciprocating pump is a piston cylinder arrangement. In rotary pump, it is rotary mechanism like a screw pump, gear pump, vane pump, low pump, in which rotary mechanism happens to suck and discharge the fluid. In a case of positive displacement pump, lubrication is required. Okay, more.
Not positive displacement pump, reciprocating and rotary.
In a case of reciprocating pump, lubrication is required, and in the case of rotary positive displacement pump, lubrication is not required at all. And in the case of reciprocating
Lubrication
pump,
not required.
high maintenance is
Lubrication
required.
is not required.
And
Yes.
in the case of rotary, there is no need of high maintenance. And rotary pump is reciprocating pump has high speed than the rotary pump, and reciprocating pump working pressure is more than the rotary pump.
Yeah, first you can Rakesh, you can first you can say that principle. You can start with the principle.
Yeah, both
This
are
is a
positive displacement type pump. So reverse piston movement is also positive displacement principle.
yeah, but reciprocating pump follows that means follows the reverse piston movement. Means I have searched in one of the MEO class 4 exam. One guy
So
YouTube
reverse
he was
piston movement
explaining.
is also a type of positive displacement principle.
Yeah, but to differentiate, you can say that as in reverse piston movement and positive displacement principle.
Okay.
Positive displacement means it is keeps on continuously. It is giving the fluid despite
And
of variation in the
one
discharge.
more. In rotary, we don't require air vessel. In a positive reciprocating, we require vessel because of fluctuating flow of the fluid. It is not continuous flow. So that's why we require air vessel in reciprocating.
Yes, that one.
Yeah, okay, let me explain. The first one is in reciprocating pump, we have the reversed piston cylinder arrangement.
Reverse piston movement, that is the principle.
Reverse
piston moment.
Okay, reversed piston movement. And in gear, in rotary pump, we have, in rotary, we have the gear arrangement. It's like that.
Yeah, in a rotary, the positive displacement principle you can say, no? Here reverse piston movement, here the positive displacement principle.
Gear arrangement or positive, okay.
In reciprocating, reversed piston movement. In rotary, positive displacement principle. Reversed piston movement is also a principle only, which is followed by the reciprocating pump.
Okay. And in reciprocating pump, we do not need any required for lubrication.
Yes.
We need or we do not need in reciprocating.
We do not need we need a lubrication. Sorry, in reciprocating we need a lubrication. You only imagine, no, between the piston and cylinder, if there is no lubrication, piston will piston will wear out. So you need a lubrication. In a rotary, you do not need a lubrication.
Basically, reciprocating pumps are low maintenance and high speed. In high speeds, they are in high speed.
In a reciprocating pump, we need a more maintenance.
Low maintenance.
No, we need a more maintenance. In reciprocating, we need a more maintenance because बार वो piston wear out होगा ना, तो हम ज़्यादा बार वो देखना पड़ता है compared to the rotary. Rotary is a simple gear arrangement.
And
hello.
Due to fluctuating, what was that? Fluctuating discharge.
Fluctuating discharge will be there in a reciprocating, and there is a constant discharge will be there in a rotary because it is a positive displacement. Yeah.
Your constant discharge and working pressure is more in a reciprocating pump.
More in reciprocating pump, less in comparatively less in a rotary pump. Okay. Another difference is air vessel. No, another difference is air vessel is there in a reciprocating pump. Air vessel is not there in this one. Rotary pump.
Yes, rotary pumps.
Yeah.
Yeah.
And this much only, I guess. Yes.
Yeah, that's more than enough, I think.
Yeah. Can you say? Can you try?
Okay, I will try. In reciprocating pumps, basically we have the reverse piston movement principle, and in rotary pumps we have the reciprocate positive displacement. Okay, in reciprocating pumps we need more lubrication, and in rotary pumps we do not need any lubrication. In reciprocating pump required in reciprocating pump as compared to the rotary pumps, and reciprocating pumps are high speed pumps as compared to the rotary pumps. In reciprocating pumps, discharge is fluctuating, and in rotary pumps discharge is constant. Continuous discharge is there. Okay, and for that we use vessels, air vessels in reciprocating pumps, and we do not use any air vessels in rotary pumps. Working pressure is more in reciprocating pumps as compared to the rotary pumps. Is it enough?
Yeah, that much is fine.
And did I miss something?
No, you told everything, I guess. Yeah, and you can add another one if you want. Cost of the reciprocating pump is less. Cost of the reciprocating pump is more compared to the rotary pumps. You can add if you want. If you forget anything, no cost ka you can.
Okay.
This much is enough, I guess. You will be satisfied. And what is positive displacement principle? Explain.
Yeah.
What is positive displacement principle?
A positive displacement principle is like whatever the amount of fluid it gets sucked, the same amount of fluid it will discharge. Is it?
No. Can I say? Okay. Despite of the variation in a discharge pressure. Hello?
Just a second. Yeah. Despite
of the variation in a discharge pressure, there will be a constant flow is maintained. That is called as a positive displacement principle. For make you understand.
You have this, na? You have this in PDF.
Yeah, everything is I am having. If you understood, or shall I make you understand instead? What is positive displacement?
Okay, just explain once and later you send me.
I will explain it. See, in a gear pump, you see the gear pump always it will be rotating. What if in the discharge side the choking happens? But despite of choking also it will keeps on rotating. It keeps on pumping the fluid towards the discharge side. It will never stop despite of variation of the pressure in the outside. The discharge pressure is varied. It कुछ फर्क नहीं पड़ेगा उसका pumping action में. That is called as positive displacement principle. Yeah, this is what it is. Okay. But if you close the centrifugal pump discharge pressure, you will close the centrifugal pump and you will on it. Yeah. Why will on? Explain this. Why will close the discharge side of the centrifugal pump and you will on the motor? Why you will do that?
Because we know that at the starting we need high torque to run the motor at a fixed RPM. So, and the flow rate is also, as we know that flow rate, if the flow rate is more, then motor has to draw more current. So, if already the motor is drawing so to current, and if the flow rate is more, motor need to do more work to draw the current,
Yes.
and with that there is a chances of that damage to the motor and insulation get damaged. So
Yeah.
to
Your internet
avoid
is breaking. I
the
cannot understand.
damage, shut the after 15 minutes. In 15 minutes, the that's okay.
Yeah. Now it's.
Okay. Do I have to explain from the starting or?
No, you explain again. Means it's better to explain. It is getting very much disturbed. I cannot understand what you saying.
Okay. As we know that the question is why we discharge, why we keep the
I will close the. I will keep the discharge
Okay.
closed while starting the centrifugal pump.
Okay. So as we know that for starting the pump, the motor has to draw on very high rate. Motor has to draw the high torque for starting the impeller, for rotating the impeller at fixed RPM, and for that the current is more. The current required be more, and the flow rate depends upon the load in centrifugal pump. As our flow rate increases, our load gets increases. So in that already we are dealing with very high load, and if we open the discharge valve, the flow rate is there, so the motor has to draw on more current. So to avoid that, so to avoid that, because if it is there, the chances of damage to the motor and insulation get damaged. So to avoid that and preventing the damage to the motor, we keep the discharge valve shut, and we open the discharge valve after 15 minutes. Because if we not do that, the pressure energy we are getting is converted into the pressure energy we are getting is converted into electrical energy. Is it like that now? It's converted is converted into heat energy, and it may cause to the motor.
Yeah, it's
Basically,
proper.
it is used for preventing the motor.
Yeah, it's fine. Proper it is. My answer would be slightly will little change. I will put my answer also so that you can, if there is any, if you can improve, you can improve the answer. So what would I have told is that we will keep the discharge valve closed, because if you open the discharge valve, the current drawn will be for the so for every pump. If you want to on the pump, we will extract the current power for an first for an to overcome the inertia. Second, for the to cause the flow. Okay. If we open the discharge valve, the power will be extraction of the power will be for both the inertia flow, to overcome the inertia, and to make the to cause the flow. For both we will extract the current. So if we close the discharge valve, the flow will be stopped. Because of that, to overcome the inertia, only for that we will extract the current, extract the power. So because of that, the less amount of power will be drawn, and if you extract the more amount of current, if you open the discharge valve, then there is a chances that the motor will get damaged. So because of that, like that,
Basically,
this would
there
be
is
my
a
answer.
inertia, and one more thing is there.
Yeah, tell.
Basically, you are just asking about the inertia, and one more thing is there. What is that?
Another one is to cause the flow.
Oh, okay. So we are just restricting to cause. We are restricting the flow.
Yeah, we will restrict the flow. If you on the as you told, no, if there is a discharge, the load will also get increased. The same principle only. It is everything is correct, but this is my answer. Means both are correct. Means like that. So I just told my answer. Yours is proper only. No, nothing, no problem.
Okay.
Then explain Faraday's law.
Basically, Faraday has two laws. The first law states that whenever magnetic flux linked with the circuit changes, an EMF is induced in the circuit, which is due to the change in magnetic flux. And the second law states that the rate of change of magnetic flux linked with the circuit is directly proportional to the rate of magnetic flux with respect to time. basically it is minus d5 by dt.
Yeah.
Okay. Negative sign shows that the direction of current that is explained by the Lenz law.
Okay, Lenz law also you can explain the Lenz law.
Lenz law states that the polarity of induced EMF in such a way that it will cause its production.
Okay. What is the temperature of evaporator in a domestic refrigerant?
In domestic refrigerant, we have the two sections. Upper one is freezer and down one is like normal. In upper one, it is minus 18 to minus 20 degree Celsius, and for the down one, it is for 3 to 5 degrees Celsius.
Okay. Please mention that it will depends on the type of refrigerant also. If you use the different refrigerant, then it will he is expecting this point only, and this is a failing question. If you don't mention the type, it depends on the type of refrigerant, then you will be rejected 100%.
Okay.
Because he did that.
Okay. Basically, it depends upon the type of the refrigerant.
And then you can tell the temperature, and if you tell the temperature, you should mention for the which type of refrigerant is this value is. If you are if you don't, otherwise you don't tell only, it's fine. But if you tell, then mention the type of refrigerant, and you have to mention that it depends on the type of the refrigerant we use. That is the main important thing. Okay. Then the next question is I had in my head. Yeah.
Ask non-technical also, na?
No, wait, I will ask you. Explain frosting.
Frosting is a process that due to the presence of moisture in the evaporator coils or in the condenser coil, like the ice will frozen on the evaporator coils. That is a frosting.
There are two causes for frosting. Okay, one is when you are putting the refrigerant inside the refrigerator. No, if there is any water content.
While filling the refrigerant.
If there is any impurities while filling the refrigerant, that will also cause the frosting. Because how you say, if you while putting the refrigerant, if there is any moisture, then it will go through the silica gel. If it through the dryer, if dryer extract the moisture, well and good. If it doesn't extract the moisture, it will go to the thermostatic expansion wall. If it enters the thermostatic expansion wall, it will get ice, means like
choked there.
It will get choked, and the thermostatic expansion wall will stop working. So this will happen. Otherwise, if it goes to the compressor cannot water is an incompressible. Okay.
Compressor efficiency decreases.
Yeah, and because it extracts more power to compress this water, but it is not getting compressed, and there will be a noise. Noise will be there. So eventually the efficiency will get decreased. So this is the point you have to tell this entire. This is the first reason. Okay. Second reason is if you keep the door open or something, the atmospheric air contains the moisture, and whenever it comes in contact with an evaporator coil is maintained at very low temperature. Okay. Then because of that, there will be a ice formation will takes place over the evaporator coil. Then while repairing also, if you try, then eventually it will get melt. Then if it get melted in the inside the piping also, sometimes it will get choked. Means like it will get freezed, and because of that the circulation will get affected. So these are the two reasons which you have to mention if the question is asked related to frosting.
Okay. Is it asked by the Briganza sir or someone else?
No, this was asked by Rishi Rana sir.
Okay.
Briganza doesn't ask this question. Briganza only asks the VCRS explanation and the temperature of the evaporator. This one he will ask. And another question is related to refrigeration. This one safety devices he will ask. Okay. These are the three questions. Then explain properties of the refrigerant. What are the properties of refrigerant?
It should have a low boiling point. It should have low condensing. Okay. Yes. And it should be non-inflammable, non-toxic, non-corrosive. It should have low global warming potential. It should have low ozone depletion point. It should not mix with oil.
Either
or
it should
should be miscible? It
totally
should be.
mixed with oil. No, no, you have to tell perfectly if you are telling with respect to miscibility. Either it should get totally mixed with oil, otherwise it should not totally does not mix with an oil. Like that. If it is an in between, then it is a problem. Either पूरा दोस्त बन जाओ या पूरा दुश्मनी रखो. बीच में रहोगे तो वैसे. That analogy you can put it in, to remember. Okay. Then continue.
Yeah, that only. Non-corrosive,
And
low global, no boiling point, low condensing. Then non-corrosive, non-toxic. Don't have bad smell. Okay, it should be. One more thing is non-corrosive, non-inflammable, non-toxic, low
and
global warming potential.
cost of the refrigerant should be less.
Okay.
That is one point.
High latent of vaporization,
High latent heat of vaporization.
low critical temperature.
Yes.
CO2
Okay.
can be proved as a very good refrigerant, but it has high critical temperature. That's why high critical or low critical?
Low. I think low critical.
It has very high critical temperature. What is critical temperature?
It should have high
It is
critical temperature, because if the critical temperature is if it is the refrigerant has
Should
more
have
than
high critical
if
temperature. Yes, it should have
yeah
high. CO2 has very low critical temperature. What is critical temperature? Critical temperature at above which fluid cannot be
the
converted into gas state. Like
yeah.
uh, there will be no phase
How,
change occur. It will be
means
either
basically what the critical temperature is. You see, there will be a
it will
continuous phase
stay
change of the there will be a continuous phase change happens in the refrigerator, right? If it is if it has a low critical temperature, the phase change transformation will be there. No, liquid to vapor, vapor to liquid, it will stop if it reaches the critical temperature. That is basically what it is. Why
it should
critical
have
temperature
low
is
critical
okay.
temperature.
Okay.
yeah.
Let me write these things. It should be chief. Okay. Low critical temperature. I think that's enough if I ask him about 7 to 8 properties.
Yeah, that much is enough. You won't dig much.
Okay. Just next question, please.
Okay. A difference between petrol engine and diesel engine.
So in petrol engine, we are using the carburetor, and in diesel engine, we are not using carburetor at all. In petrol engine, we are using auto cycle is there, and in diesel engine we use the diesel cycle. Okay.
Yes.
In petrol engine are high speed engines, where diesel engines are not high speed engines. In petrol engine we are using the spark plug, and in diesel engines we are using the fuel injectors. In petrol engine, okay, wait. That much I know, or I am not able to recall.
Okay. For same compression ratio, the efficiency of the petrol engine.
The compression ratio for petrol engine is 8 to 12,
Yeah.
and for diesel engine it is 16 to 20.
Yeah. Correct. And there will be a less noise in the petrol engine, and more noise will be.
Yeah, we need less maintenance.
Yeah, less maintenance in
maintenance is
petrol engine,
less noise is
high maintenance in diesel engine, and less
yes.
compression ratio. Because of that, there will be a less stroke will be there. The stroke length will be there. Because of that, high RPM will be there in an petrol engine, and the diesel
Yes,
engine.
improper scavenging is there also.
Yeah, that also you can answer. Then next question is what are your strengths and weaknesses?
As I am in NCC during my school time, so I know how to cope up with the new different nationality. As I was the NCC national camper, I know I did a national camp in I think in Gujarat. I think it's in the Gujarat. At that time, I was in my school, so I know how to handle the peoples from different nationalities, and I am very confident about it. I am very confident. I am very positive person. And talking about my weakness, so I think I am not very good enough in my communication skills, and currently I am working on that by practicing it daily on daily basis. So I think I will that do it more in a better way in some few days.
Okay. What are boiler mountings?
Boiler mountings are like first one is safety valves are there. There are two safety valves. Then water gauge glass indicator. They are basically tools. Then feed check valves is there. They both are two. Then steam stop valve is there. Steam pressure gauge is there. Then blow off cock is there. Okay. Then scum valve is there. Then air vent is there. Fusible plug is there. Did I left something?
No, you told everything.
Okay.
Yeah, you told everything. Okay. Explain the steam stop valve. Why it is used?
A steam stop valve, basically we are using it to stop the steam hammering, to prevent it from the steam hammering. Like when we open the valve, if we open it sudden, so as the steam goes into the pipeline, so before that maybe there is a chances of water is there. So as the steam gets in the touch with the water, it will get condensate and it will create a very bad sound in that. So to prevent the steam hammering, we are basically using the steam stop. We are using that valve.
Explain the process of the multi-stage compressor.
Process of multi-stage compressor.
Working of multi-stage compressor.
Okay, so multi-staging is a process that is used that we are used for in a compressor, like for at starting the air will get, as piston comes downward. Basically there are two. I am talking about the two-stage multi-compressors. Okay, in first stage we have the larger piston, larger compressor, and there is a one intercooler is there. Then second compressor is there, which is smaller in size than the first one. Then after cooler is there. Then we have the water bottle. So at starting the air gets sucked into the first compressor. Okay, and as the piston comes down, air will get sucked into the piston, that piston arrangement. As the piston starts moving up, it gets pressurized and the air exhaust valve opens, that the another exhaust valve open, and the air will pass into the aftercooler. Okay, then after passing through the intercooler, it will go into the second stage, and then air passes from the second stage compressor. It passes through the aftercooler, and later it goes to the air bottom.
Yes, okay.
We are using the okay.
Yeah, tell me. Yeah.
We are using that intercooler and aftercooler to reduce the work done. For intercooler, we are using intercooler for reducing the work done by the compressor, and for aftercooler we are using so that we get the more mass of water, more mass of air. For that we need that more mass of water so that we can burn more fuel. That's why we are using the aftercooler.
Yeah, you have to mention another thing, that in the intercooler, the constant pressure will remain constant and temperature will decreases. That you have to tell properly.
Okay.
If the pressure is that is the main reason why we use the intercooler and aftercooler. Pressure will remain constant, temperature will decreases, and because of that, the PV in the PV diagram there will be a decrease in the work done, which will be there. That will be decreased. Yeah. That you have to properly. Explain the marine exhaust gas to turbocharger. No, before that you explain the boiler accessories, all the boiler accessories.
Boiler accessories or mountings?
Accessories. Motifs you
Economizer is
already
there, sir.
explained. Accessories you. Yeah.
Economizer is there. Then preheater is there, sir.
Yeah.
Only two these I know.
There is economizer and preheater and another one superheater.
Yeah, superheater.
Superheater.
Supercharger, superheater.
Supercharger. Yeah.
No,
Supercharger.
supercharger is
That
not
will.
in there in boiler. There is draught system.
Superheater. Yeah. Superheater. It is correct.
Draught
Superheater,
also
preheater,
draught.
and economizer and some two other things. Yes. Tell Gyan.
Economizer, preheater, and draught system.
Uh-huh.
Draught fan.
Okay. Draught fans are there. Yeah, there are basically three draughts.
Hmm.
Natural,
I am
induced,
not clear
and
about this. Yeah.
Okay, draught system I don't know, but then economizer, preheater, and superheater. That these three things only I know. Yeah, explain about these three. Can you know? You will explain. Will you explain? It will be reversed for you.
economizer are basically used
Economizer is uses
for producing the steam.
steam, exhaust steam. Okay.
Exhaust
And
steam from the turbocharger will be there. No, this economizer basically used
No, no,
whenever the boiler is
economizer is used
running.
on board ship
Okay.
when ship main engine is off.
when
Okay.
when main engine is off or main engine is on.
Main engine is on. Gyan. Main
Like
engine is on.
when we are when we
Let
are
me write
sailing,
it
the
here. I
exhaust
have to
gas.
boiler accessory.
Yeah, the
Huh?
when while we
Hello?
are sailing, the exhaust gases. I'm clear.
Yeah. Now you are clear. Yeah, tell me.
Okay. Just put my phone. Let me put my phone there. While sailing, we are basically our engine is start now. So the exhaust gases coming out from the turbocharger is there. It goes into the exhaust pipe. Like we have the boilers in the downside with the help of the pump. We get the pump into the pipes, and the pipes are just placing in that exhaust pipe. So due to that high enthalpy, high heat energy, the water will get converted into the steam, and it goes into the steam drum.
Yes.
It's like that.
That is an economizer. Yeah, that is proper. And the preheater?
Can you explain again economizer?
Like while we are sailing now, like on the port we are burning fuel for the for producing the steam, but we can't you do it for a longer period because we do not want that our money will get go. So for that, what we do is while our main engine is on, the exhaust gas is coming out from the exhaust gas turbocharger. Na, it goes into the that pipe. It goes into the exhaust pipe. So we have the water drum and steam drum is there. So water from the water drum, if we get the water with the help of the centrifugal pump, and it goes into the pipes, and the pipes are placing in such a way that it is fitted into the exhaust gases, exhaust pipe. So when water gets when we get the water from the uh, pump, that when we get the water from the water tube now from that water drum, it goes into that pipes, and with the help of high enthalpy, high heat, the high heat is there.
Yeah, it is not accurate. I think.
It
Write it.
changes into the
Yeah, see, I will tell. In economizer is used whenever the exhaust gas from the boiler will be there. No, then that exhaust gas will go through the turbocharger. Okay, exhaust gas goes to the turbocharger, and the with the help of turbocharger, the heat whatever the heat will be there. No, that heat is utilized to increase the temperature inside the this one inside the economizer. So that increased temperature will be there, that is utilized to heat in the steam drum. It is used to heat the steam drum, whatever water will be there. No, that to heat that it is used. So basically, economizer used only whenever the engine is running. So at that time, the steam will be heated with the help of this economizer. Understood? Gyan?
Yes, little
Yeah.
bit, but I will read by myself.
Okay, okay. You once go through it.
Yeah, Praneeth sir has explained it.
Pranit sir, yeah, he only explained it. Yeah. Then air preheater and superheater, I also don't have that much means like confidence to explain. You also go through it later once. I also don't
Okay,
know properly. I don't know properly. I don't know.
Okay.
And the next question is explain exhaust gas turbocharger, how it works.
Exhaust gas, basically exhaust gas turbocharger is used to pressurize the air so
Yes.
that we can burn more amount of fuel. Okay.
Total working you explain.
Total working is there like when the exhaust gas is coming out from the exhaust valve, it goes into the exhaust. We can store that exhaust gases into the exhaust gas manifold. Okay, from there it goes into the as it passes. We have to pass it through the turbine. As the turbine moves, it rotates a shaft of the compressor, and the compressor starts sucking air.
Now this blower is used, not compressor.
Someone say it is centrifugal compressor.
It's not compressor. I have asked with Sandy Gyan.
Okay,
One person who is working in this sailor, no, I only
yeah, I
asked him.
know. Is
He told that it
okay,
is
his
a
friend.
blower. Yeah, it
Okay,
is
it
a
is blower.
blower,
No,
not
then
a.
blower will suck. Okay, then blower will suck the air from the blower will suck air, and after that, its density increases. Okay, its temperature
Yeah.
increases up to very high temperature. Then we passes the gases from the air cooler so that its density decreases and we get more mass of air. Okay, for that we have to pass it through the air cooler, and after that again go after that it goes into the inlet port.
Yeah, yes. And what is supercharger? How it
Supercharger
works?
basically is supercharger is basically work with the belt arrangement, like
Supercharger is
whenever
nothing but a compressor. It is a
is a compressor.
I don't have any idea. Let me read. Supercharger is uses the energy from the crankshaft. Okay,
Yeah,
uses.
that's what I am going to explain. Uh,
Yeah,
like
he
we
will
have
explain. Yeah.
Yeah, we have the belt arrangement is there. So as
Yeah.
our engine starts rotating, so at the simultaneously, our supercharger, like there is no turbine is there. So
Mm-hmm.
as it starts, so blower will start suck the air and it pressurize the air. And in
Yeah.
supercharger, most like 30 to 35% of the efficient
Power
30
of
to
the cranks.
35% power of the that power will get
Yes, yes.
wasted.
Yeah.
And
30 to
we use the
35% of the
supercharger.
power from no 30 to 35% of the power from the crankshaft is utilized by this blower. So there, because of that, there will be a less efficiency will be there when compared to the turbocharger. This
Only
was
30 to 35% is used.
no 30 to 35% of the power from the crankshaft will be there. No, that is utilized to for the blower to suck the air. Means
Oh,
that
okay,
one.
okay, okay, okay. Just got it. And
Got
just
it.
have a less maintenance is there, like high maintenance.
Yeah, yeah. Okay.
And
Next, okay.
one is it's a
That much only.
yeah that we
Yeah.
yeah
Yeah.
that we
Uses of compressed
like
air.
if we need
That.
like
Yeah.
if we need instant power, for that we are
Yeah.
using the
Instant power. We are choosing supercharger, and for high efficiency, we
supercharger
are
like
using
in
the
sports
turbocharger.
car.
Yeah. Yeah. In
Yes,
sports car,
yes.
we will use, and in the ships, we will use the turbocharger. Next question is,
Yes.
what is the uses of the compressed air in the ships?
Compressed air is used for starting the main engine.
Yes.
Okay, and for
Yes.
starting the auxiliary engines too,
Yes.
for ship whistle and boiler
Yes.
blowing suits.
Okay. Okay. Yeah, that much is enough. And why four-stroke is used as an auxiliary engine?
As we know that we use that four-stroke engines are high-speed in engine, so we are for starting the
Actually, two
generators we
strokes
need
are high speed
high-speed
engine.
RPMs. But in general, it is high speed, no? Not
In
on the
general,
ships.
also two stroke is high speed engine.
Yeah, that's what I'm asking, explaining that in general, two-stroke engines are high-speed engines, but here we have to burn a very bad quality of food, that fuel. That's why we are using this.
One formula is there which was told by the one person in
Yeah.
there. Hello. Now, number of the poles in a stator is equal to 120 times the frequency divided by speed of the this one synchronous speed. This is the formula. In that, the RPM of the petrol engine will be more, and we want the 60 hertz of the frequency in the generator. So, okay. Because of that, when you substitute in the formula, because the RPM of the four-stroke engine is more, so because of that, high frequency of the current will be generated in the four-stroke engine compared to the two-stroke. So because of that reason, we are using the four-stroke as an auxiliary engine. So this is the one amount of the one reason. Second reason is the main is for two-stroke engine. For main engine, we require more amount of power, and because of that, the power in the two-stroke engine which we get is more compared to the four-stroke engine, and that is the second reason. Third reason is the for in a four-stroke engine is easy to start compared to the two-stroke. So this is the third reason. So there are three reasons because of which we are using it as an auxiliary engine. Okay.
Okay. We'll write it down.
Let's wind up.
Let's move on. Okay, fine. Okay, bro, you got selected. Congratulations.
Thank you. Thank you.
What about me,
Any
sir?
feedback?
Huh?
What about me?
Ah, you also got selected, bro.